All right, let's continue with part two in our quest to understand more about diagnostic clinical laboratories. What we're going to look at for now is just reviewing staining bacteria. I've already covered this, but this is more in a practical sense of staining it, staining bacteria so we can see them for microscopic examination. Really, what we're trying to do, it's more of evidence, I say, to convict in a court of law, if you want to use that analogy. The idea is we have the actual evidence of the gram stain. It tells us it's a gram positive, gram negative, and we don't have to use the gram stain every time. It's just looking at the basic structure of itself. So obviously, the gram stain on this side over here would looks more like a staph of some kind, and it would bias me from the standpoint of tests that I would run. And that's really the purpose of using either a simple stain or a gram stain or something is to give you more evidence uh, in what direction to go, because we don't want to spend time spinning wheels, and also trying to keep the cost down. We don't want to run all the types of media that we have at our disposal. Just to review, we make smears by transferring on the microscope slide. Now, we need to make sure that the slides are clean. And again, the reason that we do this is that they're shipped with sometimes animal fat or something. And what we want to do is to make sure it's grease free. So we want to make sure that they're clean. Otherwise, you're going to be wasting your time because the bacteria slide right off. So we heat fix the bacteria once we spread the culture. We dry it in the air because we don't want to boil them. If you were to use flame now on a sample that's got liquid on it, prepared for your slide, what happens is you'll distort the bacteria because you're literally boiling them, and you don't want to do that. So you make sure that they're dry in the air. You can put it on a warming plate or something, and then pass it through the flame, like you see here with the gloved hand, and a couple passes through the flame, and that's it. And that heat fixes it. And what you're doing is you're melting just a little bit of that polysaccharide or whatever it has in the outermost to give us something to stick to. And again, let's remember that these do have animal fat, so we do want to burn off on both sides. Just pass it forward. You don't have to re-blow the glass. I just kind of burn the fat off on either side, and you're good to go. Let it cool, and then you can move it. Now, students like to make sure that they see the sample. I got to have enough on there. I'll guarantee that I'll have something gram stain. Well, actually, too much is not good, or not enough is not good. You want something just right in between, and that's sort of where we're at. I tend to like something in between these two. It's a little bit heavy for my taste, but that's okay. So when you do the staining, you cover the smear with whatever the dye that you have, and usually you wait about 30 seconds, or I usually on average about a minute or so. And what you'll notice is that the smear will take on a little bit of a darker color, and you can rinse, not wash or spray or jet spray, or don't start up uh, the uh, the water. What you may call it there, to spray off the bacteria on there. The reason behind that is you want to keep your sample on there, so making sure the water flow is really just dripping on there. Wash off any stain that got on the bottom of the slide at the time, so you can flip that around and do that. And then you make sure the iodine is the mordant for the gram stain. In other words, it helps keep the original uh, dye into the membrane. So the idea behind that, of course, is to make sure iodine is there for a period of time. I think 30 seconds is enough. Then you can run just gentle tap water on the surface to kind of gently rinse it, and then you can use bibulous paper to blot off. Don't wipe it, just allow it to kind of wick into the paper. Um, and then you place the microscope slide, the smear side up. It's usually the fritted side if it's got sandblasting on it. and you start with a 4x objective and then use flip up through the objectives until you get to the 100x typically to see, and then you can add oil to it. And that's a review just to kind of to keep your skills warm. Now obviously we don't use methylene dye for the gram stain. We use the crystal violet, and that is not represented here, but that's okay. The same kind of steps are used. The other, if we want to look at if it produces a polysaccharide or not, we use a negative stain. And what that doesn't actually stain the microorganisms, it's negative from the standpoint it doesn't stain the bacteria, but the polysaccharide surrounding it. That's sort of the idea. And we use the spirochete and the like. The spirochete is really sensitive to heat and that sort of thing, so negative stains can be used for those types of microorganisms. But the negatively charged cell, when you apply a acid stain, which is a negatively charged, so negatives repel, and so it'll keep around the surface. So we can tell if it's, you can see the spirochete here, or if it's got a polysaccharide. So the gram stain is the stain of most choice, and here the principle, of course, here's a gram positive, gram negative, and this is due to cell wall differences, which I'll review here in a minute. But you follow a procedure. I usually don't have my students memorize the gram stain procedure. You should be very familiar with it, but again, I want you to get used to following SOPs where we don't rely on our memory. We always follow directions, and that's sort of my campaign for that. SOPs are important. So here's a nice grape-like clusters, which will be your staff, and which is nice. And here you'll see sort of a blunt rod, gram negative, and it kind of looks like E. coli. I don't know, but this is the inspector's first clue as to what the causative agent might be, and then we start to think about tests that might go around and confirm our initial suspicion. So the idea is to get you enough information using your microscope and the gram stain. Having the gram stain information is enough to start antibiotic treatment, because we can use broad spectrum antibiotics for gram positive, gram negative. So that information alone is very useful. Again, I'm not going to review the gram stain in total. I just know that we have certain procedures and certain things happen as a result of the timing of which we put the chemicals onto the slide. And then obviously you can have good gram stains and poor gram stains, and you want to try to just follow the procedures and you'll get that. The crystal violet, it does go bad, and you'll start to see crystals form like that, and I would just throw it away and get some fresh. So the rest of this is just to show you various variations of having clinical specimens perhaps in your samples. But you know, it's nice to show you every time all the right things that happen with the various tests that we do, but it's also more important to show things that don't go right, because, well, if you're like me, I tend to step all over when I do something, and sometimes I get precipitation of the gram stains, or overcolorization, things like that can occur, so we try to do the best we can. Again, the gram stain takes advantage of the two. The gram plus has a peptidoglycan, a much thicker layer. The peptidoglycan in the gram negative is sandwiched by two outer, the outer membrane and the inner membrane, and so it's a totally different cat. The iodine mordant traps the crystal violet dye into the matrix of the peptidoglycan, where that's not possible here in the gram negative, and it's really the difference between these two. Very stunning. Graham was amazing to figure that out. He didn't understand what was going on, he just knew that it did work. And so we used the bacteria shapes and the gram stain to identify, at least initially, what we should go after. So obviously here's a tissue type stain that has some bacteria in it. It looks like they're gram negatives. It's kind of a crappy slide, but uh, it's a blunt rod, so it could be a gram negative rod like E. coli or something like that. I'm not really sure. At least we know it's a gram negative. And here again, here's another gram negative, and it helps us in our diagnosis. Now this isn't. This looks more like uh, a long rod of some kind, and so we can make determinations. Here's another gram negative. It's a shorter rod than before. It tends to make little equal signs. If you notice through here, equal signs, that's been my typical. It's E. coli. And again, not to trick you, but this looks like E. coli too. And so just kind of falls in between. It's a longer rod. It looks kind of suspicious, and it's with a cell, and it looks like a stain that is, well, let's go back for a second. Does it look pink or does it look blue? I would say, based on the looks, this is a gram positive, and we can use the acid fast stain, which we have to do in some cases, like mycobacterium lepri or tuberculosis. These refuse to be stained with gram stain, mainly because they don't have that peptidoglycan layer that, like we know, typically have come to be knowledgeable about. But we see a pink is positive, blue is negative, so there's the acid fast stain. I did want to review one more time the single colony isolation, or the isolation technique, is making sure that, well, first of all, you should have gloves on those hands, but anyhow, that when you're streaking, you have follow a particular streaking protocol. I like the 4 quadrant streak, and 1, 2, 3, 4, and the fourth one I kind of use more space. The idea is you want to get these single colony isolates. The reason being is I want to make sure I'm not dealing with a contaminant, or is it a mixed culture? What can I see from this? And if I do take a sample, I usually try to pull from the same clone or the same colony every time. But typically, it's a good self-check on your technique to see if you're got a contaminated culture or not. Here's a good the single colony isolation on a differential blood agar, and obviously doing that gives us a better read. A lot of times, you can see the really dense areas. And this is a beta type of reaction. It's translucent. This is most likely a strep because it's confluent. It's sort of golden brown. If you can see all the way through it and read the newspaper through it, then it's probably a staph of some kind with beta. There's a slight difference between the two. You get this golden versus the other. But anyhow, you can see the reactions. But the idea, all I wanted to show with this was doing single colony isolates, and can actually help you in your determination of differentials. So I'm going to stop there. That should give you enough. These are sort of technique reviews. You should have been already familiar with most of these, but again, it's really important in a clinical lab that we're aware of these techniques, we build on these techniques, and we're always conscious of the sterile field that's around us. So thanks for hanging in there with me, and next time I'll go over part 3. This is most exciting section. Well, it's interesting anyhow, but I'll talk with you then.